Okay. So if we look over to the sideboard here, if everyone can give their attention over to where I'm at, okay, we normally do this, right? Okay. So over on Thursday, the 6th of this fine month of December, geometry, this class, the middle section here, SWBA, what's that stand for, class? Students will be able to, Julia Page, what's that stand for? SWBA. Students will be able to, thank you. Use ASA, SAS, SSS, AAS, and HL to prove triangles congruent, which is section 4.5. We don't know what those acronyms mean right now, and that's okay. We'll learn them in a second. And we'll learn them today, and then we'll be able to read that with ease and be like, oh, okay, that's what Mr. Costa was talking about. That makes sense, okay? But we're going to use these 5 different things, girls, we're going to use these 5 different things to prove these triangles congruent. And it says that they're at section 4.5. And you guys already had flipped the 4.5 in your notes, I believe, or at least most of you had. So it starts off kind of in the middle of the page here, okay, middle of the page. And it says ASA, and it says in parentheses what? Angle, side, angle. So what do we think ASA stands for?
Angle, side.
Angle, side, angle. We kind of see that the first letter of each of these. You have the A, angle, S, side, A, angle again. So we have ASA triangle congruence. Okay, so you know how sometimes in math, okay, or a lot of times in math, it seems like the teachers teach you something, and it's a long way, and it's annoying, and then like a little bit later you learn a shortcut, and you're like, why did we learn that in the first place? We're doing the same thing here. So this is a shortcut. So today's like the shortcut day. So we did the long way on Tuesday, and today's going to be the day full of different shortcuts that we can do to prove triangles congruent instead. So we're going to say, hey, surprise, we actually don't need all 6 corresponding parts to be congruent. We only need different sets. So for this one, it's going to be an angle, a side, and an angle. So if we read through this, if 2 angles in the included side of one triangle are congruent to 2 angles in the included side of another triangle, then the triangles are congruent. I think it'd be good to underline included side, and maybe even 2 angles and the included side as well. Let's talk about what the idea of an included side means. So if we had a triangle, we could have angle 1, 2, and 3. And if we, or actually, let me back up. Instead of calling them 1, 2, and 3, let me put letters there. I like that a little bit more for this explanation. Angle A, B, and C. So if we're talking about angle A and B, what side is included in A and B? It's going to be side AB. It's going to be the side between them. So on this angle, side, angle, you can write this right around here in this kind of dead area where I'm circling right now. You have some dead area there, a little bit of dead space. I feel like that's something where you could fit this little drawing into. We're saying, hey, we're talking about angle A and B. The included side would be this one, AB. It's between those 2 angles we're talking about. It's not the other ones. It's not BC. It's not AC, because those aren't between them. It's the one between those 2 angles. It's touching those 2 angles. No. No, it could be any 3 angles, and you can pick any 2 of those angles. The side would just be one in between the 2. That make sense? Question. So we have this question here. What was the benefit? What's the benefit of using angle side angle congruence instead of CPCTC? Why would it be easier to use this than to use CPCTC? It's faster. Why is it faster? Okay, so it's faster. We do less parts. How many parts do we do for CPCTC? 6 parts. We have 3 sides, 3 angles. How many parts do we need for angle, side, angle? 3. So you need half as many. Do we think it might be easier sometimes to find half as many than it is to find 6? Yeah. So that's why this would be a benefit to use. questions on this? The initial introduction of it. Okay, we'll move on to right below this. Let's look at letter A. Letter A, bottom left of your page, right above C. We're going to determine whether these two triangles are congruent and explain our reasoning. So we have triangle ABC, triangle DEF. What do we know about this triangle so far? Let's identify any corresponding parts that might be congruent. Brief. Angle C and angle F are congruent, so we'll put one arc there. Okay, what's another thing that we know about these triangles? Jordan? Okay, and which side is that? Very good. Side A, C, and DF are both 2.3, making those sides congruent. Very good, Jordan. Okay? And now we're also told this angle is 45 and this angle is 74. Those are congruent?
No.
You think angle B and angle E are congruent? How could we prove whether angle B and E are congruent? Agree? Add 45 and 61 for this triangle ABC, the triangle on the left, getting 106, and subtract it from 180. This helps us because we can find angle B. All the angles add up to 180. We know two of them. We can find the third through this process every single time. So this is 74 degrees. So are angle B and angle E congruent, Julia?
Yeah.
Your hunch was correct. So how will we mark them? Two arcs. Very good. Two. And then if we know that two pairs of congruent angles are congruent to two pairs of congruent angles on the other triangle, then, Julia, the third angles are congruent as well by our third angles theorem. So we'll put angle A is congruent to angle D. So now, do we have two angles and the included side congruent to two angles and the included side? Angle A and C are angles. Is side AC included? Is side AC the included side?
No.
What's included side? The one between them, right?
Yeah.
Is side AC between angles A and C?
Yeah.
Yeah, so it's the included side. Two angles in the included side congruent to two angles in the included side.
How do we know that is it? Because of the 2.3 centimeters.
Yeah, we know they're congruent because they have the same measure. Does that make sense? Okay. So we can say that these triangles are congruent. Triangle ABC is congruent to triangle what? DEF by, we didn't use CPCTC this time, we used
ASA.
very good. We use ASA, angle, side, angle. We use angle, side, angle. We said angle, included side, angle. Angle, included side, angle. Now, if you look at ASA, where is the side at in comparison to the angles? Where is the side at compared to the angles? In between them. Is it included between the angles? And where is our side at have to be in our triangles? Between the angles, right? So it's kind of in that word, in that acronym there. Questions on this first one?
I do.
Okay, what's your question?
I don't really get the included sign thing.
Okay.
Like,
So, if you're being included, that means you're being kind of brought into something, right? Okay. So, that means if you're being brought into something, you're probably near those people, right? So, if someone's including you at their lunch table, they're probably having you come and sit at their table. So, you're with them, right? So, we have this triangle here, right now, this triangle ABC we just used. If angle A and C are including a side, it's going to be the side that they're both touching, right? They're both going to be by that side. Are angle A and C both by side BC? No. Are angle A and C both by side AB? No, only angle A is. Okay, angle C is not by this one. Angle A and C are only by side AC. So that's the included one. It's being included by both of them. They're both saying, hey, come here. You're welcome. We're including you. And so they're both including that side. Does that make a little more sense? Okay, good question. That's a very important concept, this included side. And whenever we don't get a concept, it's important we ask. So thank you, Paige, for asking. Let's look at this letter B to the right of where letter A is.
That don't make sense.
What doesn't make sense?
B, I'm trying it, and I added the 2 to figure out P, and it came up with 69.
Okay, so what Julia's saying is, hey, she's kind of working ahead a little bit here, and she's saying she's trying to figure out this third angle P. She's saying, I wonder what that is. She noticed that 31 degrees is screwed to 31 degrees. And 62 is congruent to 62. These sides are congruent, JL and PM. Okay? So she noticed those things. She noticed angle M and angle J are congruent, and side JL and side PM are congruent. She said, hey, we need one more angle. As a matter of fact, we need angle P, because that would make this side PM included, because both angles would be touching that side. So she said 31 plus 38 was 69 degrees. And if we subtract that from 180, we'll figure out what our mystery angle is. And we get 111. So if this is 111 degrees, is this congruent? Is angle P congruent to angle L? No. So we can write, hey, angle P is not congruent to angle L. Let's go ahead and write that down. Angle P is not congruent to angle L. And then K would be 39 degrees, so we know that as well. Now, if we know that these two angles are not congruent, are these triangles congruent? No, because all corresponding parts have to be. This is just a shortcut we can use, but if we prove something wrong in the middle of it, that doesn't work. We don't have angle included side in the other angle. So we say not congruent. And that could be our explanation. Not congruent, and it's because angle P is not congruent to angle L. If they're not congruent, that's enough of an explanation, right? Do we need to say any more? No, we know that two corresponding angles aren't congruent. That's enough of an explanation right there. Because it doesn't work then. Questions on that? Okay.
You want us to write down the included side.
What do you mean write it down?
Like, say on number 8, do you want us to write that down as an answer too? So
That it's included? You don't have to write that down.
I didn't know if that was like a part of the program.
No, just this was. Because we can look at the picture and identify it. So if you show me on your picture what's congruent, so you ask a good question. Basically asking, hey, what do I want from you guys on these problems as your answers? So what I want is I want you to mark your picture. And she was saying, do I need to write down that AC and DC, those sides, or AC and DF are included sides? No, you don't. If you show me on your picture this, I will know that what you're doing if you said ASA. I'll know exactly what you're doing. Good question. I am going to pick up the pace a little bit, so just a heads up on that, guys, okay? So just a heads up. I'm going to ask you guys to dial in, okay, for these last 31 minutes here. Okay, 31 minutes. I'm going to ask you guys to kind of dial in a little bit more. We've been doing great so far. I'm going to ask us to just dial in a little bit more. So this is one of our longer section of notes. So if we have letter C, we're just going to talk through this. We don't actually have to finish it right now. We're just going to talk through it. What do we know about this picture right now? Bree. There's a 90-degree angle. What else do we know about this picture? Levi. Angle B and C are congruent. They're marked for us with one arc. What else do we know about this picture? Dominic?
Side BD and side DC are congruent. There, mark with one tick mark. What's one more thing we know about this triangle? Eric?
They're supplementary.
What's supplementary? Okay, angle BDA and angle ADC are supplementary, meaning they add to 180. And how does that help us, Eric?
Well, one of them is 90, so the other one has to be.
1of them's 90, so 180 minus 90. The other one has to be 90. So these two angles are congruent. Do we have enough to prove these triangles congruent now? Yeah, because we have an angle, two angles, and the included side, correct? I changed my mind. We're actually going to finish it because we're right here. Triangle what is congruent to triangle what? Who can give me a congruent statement here? Okay. 3. Very good. And you did a good job of saying the order of those. Triangle ABC is congruent to triangle ACD. Here from the top to the outside to the middle. Top, outside, middle. By what? Very good. By ASA. Angle, side, angle. We're going to have a lot of these congruencies, congruent shortcuts. So we have to label which one we use. That way we know. And that's going to help us kind of remember some of them too. It's kind of twofold, helping me know what you're trying to say and helps you remember. Questions on letter C. Okay, if you flip the page there, here's what we're going to do with A and B. Crossing them out. Okay, we're skipping past those. Okay, go down a little bit further, look at letter C. Boom. Go down a little further, you run into SAS. What does SAS stand for? Side, angle, side. Very good. So we have side, angle, side, triangle congruence. This is another shortcut. This will be our second shortcut. We had angle, side, angle. Now we have side, angle, side. This says if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So this time, instead of having two angles and an included side, we kind of like say, whoa, let's reverse two sides, and the included angle. So just like the idea of the included side would be between the two angles, the included angle would be between the two sides, where the two sides meet. So if we look down to letter A here, we're going to start using this. What do we know about this picture? Go ahead and raise your hand and tell me some things that we might know about this picture. Dominic. Okay, side JL is congruent to side PM. We know that because they have the same measure of 46. What's another thing we know about this? Eric?
Side JK is congruent to side NM.
Very good. Side JK is congruent to side NM because they're both the same measure. JK. Okay. And what else do we know about this picture, Ronnie?
The angles are congruent.
Which
J and M.
angle J and angle M are congruent. They're both 37 degrees. Very good. So, do we have enough to use this triangle congruence theorem? Thank you. Okay, do we know enough to prove these triangles congruent now? Not by an old one, but we do by a new one. We have two sides, and we have what kind of angle? Included angles between them, right? This angle J is between these two angles, or these two sides. To me, this angle J is between the two sides, and this angle M is between these two sides. So we can say triangle what is congruent to triangle what? I'm going to put you on the spot here, Jordan. Okay, is congruent to triangle I agree with the M. Let's look where it goes. From J to K, it went the two tick marks, right? M to N, the two tick marks. P. And what did we use here? Very good. We used SAS, our side, angle, side. And once again, this is just an abbreviation. Side, angle, side. Questions on that? Okay. So let's look at this next one, letter B. Okay, start telling me some things we know about this triangle. Joseph. I agree. That segment or side AC is going to the segment or side DF because they're both 19 centimeters. Very good. Tell me one other thing we know. 3. Okay. Line segment AB is going to line segment ED because they're both congruent. Eric. Okay, why do you say those triangles are not congruent, Eric? Okay, so Eric's saying, hey, we need the included angle. The included angle for this left triangle would be A. The included angle for the right triangle would be D. We need those to be congruent as well, but they're not. So we say angle A is not congruent to angle D, so they're not congruent. Or you can say not congruent and then have this explanation. But Eric did a good job of saying, hey, wait, they wouldn't be congruent. We got this far. And we said, oh, but they're not congruent. Because those included angles is where we kind of fail here. Or it kind of fails our congruency.
Why did you put so not congruent?
We know this, so we know they're not congruent. It's just saying, so not congruent. Yes, Eric?
On the homework, could we just put like the not congruent symbol?
You could, but I would also want you to have this explanation here. Yes, you could put the not congruent symbol for the triangles. Okay, questions on A or B? Okay, we're going to go to the next page. Cross out C.
Do it. I want to see this.
Right, bet.
What are we betting?
Right? Okay, and we're going to cross out A and B. Or actually, first, real quick, sorry, if you already crossed it out, I'm sorry. We're going to cross out B. I want to do one thing on A before we cross it out. On the next page, I want to do one thing on A before we cross it out. What's a perpendicular bisector? BD is a perpendicular bisector of AC. What's that mean? Okay, Dominic's kind of showing me with his hands. What's that mean, Dominic? One crosses the other. How do they intersect? Caitlin? Okay, straight down the middle, so it cuts this in half. And what else? That's the bisector part. What's this perpendicular part mean? No? They intersect at one point to form what kind of angle? 90-degree angle. They form a 90-degree angle. Complementary is two angles that add to 90. So they intersect to form 90-degree angles. They intersect to form 90-degree angles. So that's what this would mean. Do we have enough to prove these triangles congruent on A?
Yes.
We do?
No. We need another side.
We need another side. Specifically, we need a specific side. What?
B, D.
We need BD. What do we know about BD?
Yourself.
It's congruent to itself, right? So are these triangles congruent? Because BD is congruent to itself. So we have side, angle, side. Side, angle, side. Two sides in the included angle. Somebody give me a congruent statement.
Triangle A, B, C is congruent to triangle C, D, B.
Very good. By
By, wait,
It'd probably be good if we said, if when we write SAS, we think side angle side. Or if we say side angle side when we see it, because that'll help us remember what it means. If we say SAS, we might forget, oh, side angle side. Okay, we are going to cross out B. Questions on A? Okay, we're moving on to our third triangle congruent shortcut. SSS. SSS. No. SSS. Side, side, side. We're all about the sides this time. Triangle congruence, not an angle in sight. If three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. Three sides of one are congruent to three sides of another. They're congruent. We're going to skip A. Okay, and we're actually going to start with B, and then we'll come back to, or we're going to start with C, then we'll come back to B. We'll come back to B, don't cross out B. We're going to start with C. Okay, we're going to start with C. What do we know about the triangles on C? Reed, give me one thing we know. Geo, yeah, very good. So line or segment or side, KG and segment or side, GL are congruent. That's marked for us. Quentin, what's another thing we know?
Side KJ is congruent to side LJ.
Very good. Side KJ is congruent to side LJ. Dominic. Side GJ is congruent to side GJ. So do we have all three sets of sides congruent? Okay. So is this enough to prove it congruent by side, side, side?
Yeah.
Yeah.
So then every time.
Tanner, give me a congruent statement.
Triangle JKG is congruent to triangle JLG.
Very good. Triangle JKG is congruent to triangle JLG. Did the right order and everything. Yes, Julia.
Would it work if I put triangle GKJ is congruent to triangle GLJ?
Yeah, that'd work. Okay, going back to B. To be or not to be. Does anybody still need this? Okay. Going back to B. I said don't cross it out.
I crossed out the wrong B.
Oh, watch. Okay. So let's look at this B. What do we know about this? These two triangles. Lizzie, tell me one thing. Okay. Side PM is congruent to side. Did you say PN or M? Okay. Side PN is congruent to side RS. I agree. They're both 38 inches. Paige, give me another thing.
Side RS is congruent to PN.
That's what Lizzie just told me.
Okay,
Oh,
side
no. PM is congruent to QR. I mean QS, sorry.
Side PM is congruent to side QS. Okay, Eric, what are you saying?
Side MN is not congruent to side RQ.
Side MN is not congruent to side RQ. So are these triangles congruent? No, they're not congruent. Okay?
Can I ask you?
Yeah.
Just by these two being congruent by the RSPN and
Yep.
the QSPN, could we prove that S and P are congruent?
No. Order. No, we cannot. That's a good thought though. Okay? Eric.
Would it be the answer if you just put the top part, and didn't put not congruent, because it already has.
Like you just put this?
Yeah.
I want you to put the triangles are not congruent though. I want you to state the triangles are or not congruent. So you need to state that, yes. Because this second part here, this is about the triangles themselves. So we could even put like triangles are not congruent. That's really what we're saying. So moving on from this one. We're gonna skip this bottom one. And just like that, we're on to angle, side. This is our fourth one. We're cooking through them today. We're cooking through them. This is our fourth one. Angle, side, triangle congruence. If two angles and a non-included side are one triangle are congruent to the corresponding angles and non-included side of another triangle, then the triangles are congruent. So we're saying if two angles of one triangle are congruent to two angles of another triangle and a non-included side, the same non-included side. So instead of having the included side like we had with angle, side, angle, the first one we learned, we're going to be switching it up. We're saying, hey, let's have the non-included side now, and we can make this work as well. So if we're given that segment AC is congruent to segment EC in this picture, let's mark that. AC and EC. So go ahead and mark that. And we're also given that line M is parallel to line N. So let's mark that. We're trying to prove that triangle ABC, this bottom triangle we see here, is congruent to triangle EDC, this kind of top triangle we see here. Well, these two lines are parallel, and they're cut by a transversal going this way, or they're cut by another transversal going this way, right?
Yeah.
So what do we know about two parallel lines cut by a transversal? Think back to chapter 3. We know some different things about these angles. Do we know anything specifically about angle BAC and angle DEC? If we have two parallel lines cut by the transversal A to E. Okay, don't look at where my arm's at. See, that covers that line up. And we look at these two angles. What do we know about those two angles?
Wait,
Levi?
They're congruent.
Why are they congruent?
Alternate exterior angles.
They alternate sides of this transversal, but they're what of these two lines?
Interior.
Alternate interior angles. Angle BAC and angle DEC are alternate interior angles. They alternate sides of the transversal, AE, and they're both interior, lines M and lines N, the parallel lines. So they're congruent. Alternate interior angles are 100% of the time congruent if those lines are parallel. Does that mean we know anything about this angle and this angle?
Aren't they the same thing?
They're the same thing. They're alternate interior angles as well, but with this other transversal instead. So we cover up this one with this transversal. They're also alternate interior angles, and thus they're congruent. Do we have two angles in the corresponding non-included side?
Wait, say that one more time.
Do we have two sets of angles and the corresponding non-included side?
Yes.
Yeah.
Yes, we do.
So
They're
then
congruent.
So these triangles are congruent. So triangle ABC is congruent to triangle EDC by AAS. We won't have that one. It doesn't exist.
I didn't mean to.
I know. Something. Tell me. I'll tell you. That's something every geometry teacher expects when we teach this section. Is that to come up?
Why just went
I know. And I know you weren't doing it on purpose. It's gonna come up one way or another, whether it's purposeful or coincidental. Questions on this one?
Is that why there's SAS instead of
No, that's because the angle is included between the sides.
So
So you have to be careful.
Side,
No, it doesn't exist. And nor is there side-side angle. So, let's look at this one. If we're given angle A is congruent to angle D. Well, if we're doing angle, side, we probably need another angle and a non-included side, right? Who can tell me something that we might know here? Okay, Dominic, what are you thinking? How do you know angle B and angle E are congruent? I don't see any measures. Okay, so it's a what kind of angle? Okay, they're both right angles. They're both right angles. We can tell by looking at this graph. They're both right angles. So they're both congruent. Okay? Now could we find
Take it out.
a non-included side that's congruent as well? Paige, what do I do there?
Angle BC and angle EF are congruent
Side BC and side EF. How do you know they're congruent?
because I counted the little boxes and they both equal 3.
Ah! Since they're straight left and right and straight up and down, we can count them. That makes it easy. We don't have to do the distance formula, Pythagorean theorem. We can just count when it's straight left and right or straight up and down. That's nice. So this is 3 long and this is 3 long. So do we have enough to prove these two triangles congruent? Agree? What are you trying to say? Sorry, what were you trying to say?
Well, we do. Because we did, right? Okay. But angle or side AB is congruent to DE.
We can also find side AB is congruent to side DE. So could we use angle, angle, side, angle, angle, side, angle, angle, side, or angle, side, angle? Okay, so we could do angle, angle, side, or we could do angle, side, angle, right? We could do either. So some of these we could do both multiple on. So if you're asked on a test or a homework, and there's multiple you can do them on, either could be right. So somebody can give me the triangle congruence for this one.
ABC
Triangle ABC,
is congruent to DE.
triangle DEF. I agree. By AAS, angle, angle, side. We also could use angle, side, angle if we wanted. Questions on that one? Okay, we're getting close. We're getting close. We have one more left because we're skipping 3. So we have one more shortcut left. We made it through 4 of the shortcuts today. We have one more shortcut left. We're almost there, class. Okay, let's get this bread. Let's get this bread. Okay, even if you're gluten-free, we can still get this bread right now. Okay, John. We have HL. Stands for hypotenuse leg. Does anybody know what kind of triangles have a hypotenuse? Caitlin. Right triangles. They have a right angle. Right triangles are the only kind of triangle that have a hypotenuse. So what do we think the only triangles we can use hypotenuse leg on are? Right triangles. We can't use hypotenuse leg unless it has a hypotenuse, right? Can't use hypotenuse if it doesn't have one. So hypotenuse leg, if the hypotenuse and the leg of a right triangle are congruent to the hypotenuse and the leg of another right triangle, then the triangles are congruent. Everybody look at this drawing at the top right of your paper, please. Hypotenuse will 100% of the time be opposite or across this right angle. And it's always the longest side. So for a right triangle, it'll 100% of the time be opposite or across that right angle. And it's the longest side. And a leg, either of the other two sides touching the right angle are a leg. Okay, so we have this triangle here, and this can be a little confusing, right? What's our trick when we have these triangles kind of put together? Split them apart. So if we're talking about hypotenuse leg, we're probably going to do the right triangles, right? So notice how I split these apart. So what kind of triangles are these? Right triangles. Do we have a set of legs congruent?
Yeah.
Yes. So what do we need?
Wait.
The hypotenuse. We need the sets of hypotenuse to be congruent. Do we know if the hypotenuse are congruent?
No.
Someone said yeah. Who said yeah? Tommy, did you say yeah? Someone say yeah?
I am saying yeah now.
Oh, why are you saying yeah now?
Because in the first drawing, they shared WX.
In the first drawing, WX is the same, right? Is WX congruent to WX? Is it the same length as itself? Do we have enough to prove these triangles congruent now? We have the hypotenuse and a leg congruent to the hypotenuse and a leg. So we can say, yeah, triangle WXV is congruent to triangle. We'd have to say XWV. Or XWY, excuse me. By, what did we use? HL. Questions on that one, class?
Oh, no, no, no.
Yeah, I know we're cooking. Thank you for staying up with me. I appreciate it. We're gonna skip B, crossing out,
Yay.
moving past it. Ja, ja, ja. Okay, here's the summary. We went through all 5 of them. Here's the summary. Middle of your page. These are the ones we can use. SSS, side, side, side. Side, angle, 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 side, and hypotenuse leg. We do not have side, side, angle, or the reverse it if you're thinking naughty, and AAA, angle, angle, angle. Okay, those do not exist. And it's not even just because we don't want you guys to flip this one around and have a bad word. It's actually because they don't work. They legitimately do not work. If you have those, we're not going to talk about it now because of the time, but if you have those, it won't even work. We're not going to do these together right now. But if you look on the next page, top of the next page, very top of the next page, kind of this drawing. And here is a visual representation of all these different methods that we can use. So this might be really helpful for anyone who's visual. They can say, hey, back of this note sheet, this is a spot that I can look at. So maybe even put a big star on there or highlight it or something. That those are the ones we're using. Yeah, I see you have a Snapchat.
I do? Yeah,
Okay, we do have homework. I appreciate you guys keeping up with me that whole time. That was really awesome. You guys knocked it out of the park. It's knocked it out of the park today. That makes me so proud. It's like a proud dad moment, you know? Ja, 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 ja. We don't have class tomorrow. Good news.
Oh, wait, it's still Monday.
So, about Fun Sock Friday, guys. You guys don't have me for class tomorrow. But if you guys want, you guys are still more than welcome to come up and see me in the hallway and say, hey, Mr. Costa, I see your fun socks. And you bet I'll come show you.
well, I guess you got on your plane here, make that trip.
Are you just going to the lunchroom and just like yell for the entire lunchroom?
Library is closed. That the library will be closed.
Hey, voices off. This is good information that you guys probably want to know right here. We are not going to do these problems. These 5 problems, 11, 14, 16, 21, and 23. Mr. Costa is cutting some off. Maybe 4 extra. Wow.
We appreciate it.
Oh, okay. I wasn't as bad. I appreciate you.
Aww.
Yeah, wholesome, right? Very wholesome. What are you talking about? I mean, we have a minute left.
Oh.
Get it done.
Do we have advisory tomorrow?
No.